Cruise control is a system that automatically controls the speed of a motor vehicle. The system is a servo mechanism that takes over the throttle of the car to maintain a steady speed as set by the driver. History. Speed control with a centrifugal governor was used in automobiles as early as 1900 in the Wilson-Pilcher and also in the 1910s by Peerless. Peerless advertised that their system would maintain speed whether uphill or down. The technology was adopted by James Watt and Matthew Boulton in 1788 to control steam engines, but the use of governors dates at least back to the 17th century. On an engine, the governor adjusts the throttle position as the speed of the engine changes with different loads, so as to maintain a near-constant speed. Modern cruise control was invented in 1948 by the inventor and mechanical engineer Ralph Dieter. His idea was born out of the frustration of riding in a car driven by his lawyer, who kept speeding up and slowing down as he talked. The first car with Dieter's system was the 1958 Imperial using a speed dial on the dashboard. This system calculated ground speed based on drive shaft rotations off the rotating speedometer cable, and used a bidirectional screwdriver electric motor to vary throttle position as needed. A 1955 U.S. patent for a constant speed regulator was filed in 1950 by M. Sergeant Frank J. Riley. He installed his invention, which he conceived while driving on the Pennsylvania Turnpike, on his own car in 1948. Despite this patent, the inventor, Riley, and the subsequent patent holders were not able to collect royalties for any of the inventions using cruise control. In 1965, American Motors introduced a low-priced automatic speed control for its large-sized cars with automatic transmissions. The AMC Cruise Command unit was engaged by a push button once the desired speed was reached, and then the throttle position was by a vacuum control, directly from the speedometer cable rather than a separate dial on the dashboard. Daniel Aaron Wizner invented automotive electronic cruise control in 1968 as an engineer for RCA's Industrial and Automation Systems division in Plymouth, Michigan. His invention, described in 2 patents filed that year, with the second modifying his original design by debuting digital memory, was the first electronic device in controlling a car. 2 decades passed before an integrated circuit for his design was developed by Motorola, as the MC14460 Auto Speed Control Processor in CMOS. The advantage of electronic speed control over its mechanical predecessor was that it could be integrated with electronic accident avoidance and engine management systems. Following the 1973 oil crisis and rising fuel prices, the device became more popular in the U.S. Cruise control can save gas by avoiding surges that expel fuel while driving at steady speeds. In 1974, AMC, GM, and Chrysler priced the option at $60 to $70, while Ford charged $103. Operation. The driver must bring the vehicle up to speed manually and use a button to set the cruise control to the current speed. The cruise control takes its speed signal from a rotating drive shaft, speedometer cable, wheel speed sensor from the engine's RPM, or from internal speed pulses produced electronically by the vehicle. Most systems do not allow the use of the cruise control below a certain speed, typically around 25 miles per hour. The vehicle will maintain the desired speed by pulling the throttle cable with a solenoid, a vacuum-driven servo mechanism, or by using the electronic systems built into the vehicle if it uses a drive-by-wire system. All cruise control systems must be capable of being turned off both explicitly and automatically when the driver depresses the brake, and often also the clutch. Cruise control often includes a memory feature to resume the set speed after braking, and a coast feature to reduce the set speed without braking. When the cruise control is engaged, the throttle can still be used to accelerate the car, but once the pedal is released, the car will then slow down until it reaches the previously set speed. On the latest vehicles fitted with electronic throttle control, cruise control can be easily integrated into the vehicle's engine management system. Modern, adaptive systems include the ability to automatically reduce speed when the distance to a car in front, or the speed limit, decreases. This is an advantage for those driving in unfamiliar areas. The cruise control systems of some vehicles incorporate a speed limiter function, which will not allow the vehicle to accelerate beyond the preset maximum. This can usually be overridden by fully depressing the accelerator pedal. On vehicles with a manual transmission, cruise control is less flexible because the act of depressing the clutch pedal and shifting gears usually disengages the cruise control. The resume feature has to be used each time after selecting the new gear and releasing the clutch. Therefore, cruise control is of most benefit at motorway, highway speeds when top gear is used virtually all the time. Advantages and disadvantages. Some advantages of cruise control include its usefulness for long drives across highways and sparsely populated roads. Some drivers use it to avoid subconsciously violating speed limits. A driver who otherwise tends to subconsciously increase speed over the course of a highway journey may avoid speeding. However, when used incorrectly, cruise control can lead to accidents due to several factors, such as speeding around curves that require slowing down, rough or loose terrain that could negatively affect the cruise control controls, rainy or wet weather could lose traction. Adaptive cruise control. Some modern vehicles have adaptive cruise control systems, which is a general term meaning improved cruise control. These improvements can be automatic braking or dynamic set speed type controls. Automatic braking type. The automatic braking type use either a radar or laser setup to allow the vehicle to keep pace with the car it is following, slow when closing in on the vehicle in front and accelerating again to the preset speed when traffic allows. Some systems also feature forward collision warning systems, which warns the driver if a vehicle in front, given the speed of both vehicles, gets too close. Dynamic set speed type. The dynamic set speed uses the GPS position of speed limit signs from a database. Some are modifiable by the driver. At least one, Wikipedia, incorporates crowdsourcing, so driver input is shared, improving the database for all users. Non-braking type. The speed can be adjusted to allow traffic calming.